Good afternoon, students. My name is Ava Brown Mothersill, and today I will be sharing with you addition and subtraction of algebraic fractions. Before we start, we are going to revise two main topics that's associated with algebraic fraction, namely finding the LCM of a set of numbers or terms and the addition and subtraction of fractions. First, finding the LCM of a set of numbers. LCM. M is the most important word there. Multiple. Multiple means big. So we are looking for a number that is equal to or bigger than the biggest number in the set. Now, because it's a big number, the most ideal number to start with the set is the biggest number in the set. Now, let us use the example. Find the LCM of 6, 9, and 12. I'm sure you have been exposed to several methods. Now, remember, do not change the method you are most comfortable with. Stick to that method as we go through some of the methods for finding the LCM. Now, the first one is what I call multiple listing method. You won't find that in any book. Now, in this approach, we write down the numbers. Remember our number? 12, 9, and 6. So we are going to start with the biggest one, 12. And I like to write multiples of 12 at the first 5 multiples and pause and then move on to the next number. So the first 5 12 multiples, 12, 24, 36, and 40, 48, and 60. Now, 9, the multiples of 9. We have 9, 8, 27, and 36. Now we are at a common multiple, 36. Now we are going to the next number and see if we can find, to see if 36 is also a common multiple. Now, the 6 times table, 6, 12, 18, 24, 30, and 36. Ha! We're there. 36 is the first number that is a multiple of all 3 numbers, 12, 9, and 6. Hence, 36 is the lowest common multiple of 12, 9, and 6. Now, the second approach we're recapping is the timetable remainder approach. Pretty similar to the approach we just completed. Now, in this approach, as before, best number to start with is the biggest number. And we do the timetable. But this time, as we do a multiple, we are checking if when we divide the other numbers, we have a remainder or not. So 12 ones, 12. 9 into 12 will leave a remainder. So 12 definitely is not the LCM. Next, 12 times 2, 24. 9 into 24 will definitely leave a remainder. So 24 is definitely not the LCM. The next is 3. 12 threes, 36. 9 into 36 equals 4. We have no remainder. So 36 could be the LCM. Now let us check the next number. It is 6. 6 into 36, 6. No remainder. So 36 is definitely the LCM. Remember, you must use the approach that you are comfortable with. Now let us look at the third approach. Now, that's the prime factor method. Now, in this method, we are going to write the numbers as product of its prime factors. In so doing, we once again start with the biggest number, 12. Now, writing 12 as product of its prime factor, 2, 3, and 2, 2, and 3. Sure you remember the factor 3 in doing this. 9 is 3 times 3. 6 is 2 times 3. Now the LCM, how do we get the LCM? Having written the number as product of its prime factors. First, once again, which number do we start with? That's correct, the biggest number. So 12, so we have 2 times 2 times 3. We write down all the prime factors of 12. Next, we move to the next biggest number, and that is 3 times 3. We have to check to see if we are able to find 2 3s in what we already have. No, we were not able to find 2 3s. And hence we have to add another 3. Now we move to the next number. It is 6. 6 is 2 times 2. Now look at the numbers we have and we ask ourselves, are we able to find 1, 2, and 1, 3? Yes, we can. Here we have 1, 2, 1, 3. So we have nothing to add. So multiplying those, we have 2 times 2 times 3, multiplied by 3, and that gives us 36. Now we have done it 3 ways. And in the 3 ways, we realize we get the same answer. Remember, stick to the method you love most. Now, the indices method. Now, the indices method is really a method in preparing us to do algebraic LCM, the LCM of algebraic terms. Now, in this approach, pretty similar to the approach before, but this time we write the numbers, having written them in prime factor, we write them in index form. So 2 times 2 will give us 2 squared. I'm sure this notation is a bit new to you, but in typing, often we can't find that square depending on the program we are using. So 3 times 3 is 3 squared. 2 times 2 is 2 times 3. Now, having written it in index form, what's the rule? Do you remember that? Okay, the rule here is, first we multiply all the different base together. Remember, it's multiple. So we are not looking for, we need all the different base. So the different base are the 2 and 3. So we multiply them together. Now the second step, it's a multiple. So we are going big. So we are going to take the highest power associated with each base. Now the highest power for 2, let's go back and check. The highest power for 2 was 2. And we found that in 12. The highest power for 3 was also 2. Just coincidence. And we found that one in 9. So the LCM is 2 square times 3 square. 2 square, 4. 3 square, 9. Once again, the LCM is 36. I must once again remind you, to find the LCM, use the method you are comfortable with. Don't change to a new method. Now, algebraic term. The indices method really prepares us for terms. Terms mean numbers and letters. So, the LCM, in doing that, what do we do? Please try this one before we proceed. Remember, it's the indices method, especially for the letters. Okay. Now, step 1, we're going to find the LCM for the numbers. 6, 9, 12. We just did that and we realized that was 36. That's the first step. Step 2, we use the indices method to find the LCM for the letters. Now in our question, the common letter, no, not the common letters, all the different letters we are using. So the different letters we have are A, B, and C. And what power do we take? For each letter, we take the highest power. Now, the highest power for A in these 3 terms is 4. The highest power for B, that's correct. It is 5. And the highest power for C, remember, no power written, the power is 1. So it's just C. Now to get the LCM for the algebraic term, what do? Multiply the LCM for the number and the LCM for the letter. Now that ends the revision for LCM. Now, second revision, addition and subtraction of fraction. Now, the concept for addition and subtraction of algebraic terms follows exactly the same step as arithmetic fraction. Now, let us look at an example. Now, here's an example. Now, I'm going to ask you to do this example, but as you do it, I want you to think about what you're doing and not just think, but to write down the steps, because these are the steps we are going to apply to the algebraic fraction. So take a few minutes and do this, and remember, please write down the steps, not just to do it. Now, first step, did you have this? Write the fraction so we can see the numerator and the denominator clearly. That's extremely important. So, if you have a mixed fraction, you're going to write it as an improper fraction. As seen, 2 and 4, 9. We write that as 22 over 9. You do remember how to convert mixed fraction to improper fraction. Just in case you don't. Here it is. Listen keenly. 9 times 2 is 18. Then we plus 4, the numerator. So it is the denominator multiplied by the whole number, 9 times 2. And then we add the numerator, and that will give us 18 plus 4, which is 22. Now, the second thing to note, you notice how this fraction is written with a slash? That can create some problems. So, instead of using a slash for the fraction, what are we going to do? Write a horizontal line for the dividing bar. Right, that's correct. So we write 1 in the numerator, a horizontal bar, and 6. Now, the next number, 3. What type of number is that? You're correct. Brilliant. It is a whole number. Now, how do we convert a whole number into, so we can see the numerator and the denominator? Oh, brilliant, brilliant. Now we write it so that the denominator is 1. So we put the 3 in the numerator and we make the denominator 1. And once again, we're at another one where we have a diagonal line for the dividing bar. No, no, no. Writing it so we see numerator and denominator clearly, we use the horizontal line. Now, several times we don't pay attention to this step 1, but it's extremely important, especially when we reach the algebra. Yes, very important. So let us practice it and when doing arithmetic. Step 2. I'm sure that's what you wrote down. The LCM of the denominator. Have you ever seen the term LCD? Yes, we mathematicians don't like to write a lot. We like shortcuts. So instead of saying LCM of the denominator, we say LCD. Lowest common denominator. Now, our denominators were 9, 6, 1, and 12. What's the LCD? That's correct, 36. Remember, that's what we did when we were revising the LCM of numbers. Now, step 3. Was that what you wrote? Write each fraction as its equivalent fraction with denominator equal to the LCD. Now, one of the easiest ways is that we write one long dividing bar. And that means that the denominator, all of them have a denominator of 36. How do we get the numerator for each one? We say 9. That is indeed correct. It's 9 into 36. Gives us 4, and then we multiply the 4 by 22. And the others are the same. 6 into 36 gives us 6, and we multiply the 6 by 1. Please remember, it's minus to write back our sign. 1 into 36, that's 36. And we multiply the 36 by 3. Next, 12 into 36. That's correct, 3. And we multiply the 3 by the numerator, 5. And computing, we have 88 minus 6 plus 108 minus 15. Now, as we simplify that, we need to remember the laws for addition and subtraction of directed numbers. You remember those shortcuts? Yes? That's brilliant. That is 1. When the signs are the same, we add and keep the sign. And what is the other one? That's correct. The other one is about when the signs are different. When the signs are different, we subtract and keep the sign for the larger one. That's an effective shortcut. Remember, same sign, add, whether it's positive or negative. Different sign, subtract, and keep the sign for the larger one. So 88 minus 6, different signs. So we have 82. 82 plus 108, same sign. And so we have 100 and that's correct. And then we minus 15. And now we have 175. Step. Now, did you notice your answer? It was written, it was an improper fraction. Do we leave our answers in proper fraction generally in arithmetic? No, we don't. Once we're doing arithmetic, we now convert the improper fraction to a mixed fraction. And that's it. We are now finished with the addition and subtraction of fractions. I do hope you remember those were the steps you wrote down. And this revision helps as we prepare for addition and subtraction of fractions. Algebraic terms. Now let's get into the big one. There is one. You wrote down the steps. Now apply the steps to this. I am giving you the opportunity to apply the steps before I work it for you. Please. Okay. What was the first step? Write the fraction so we can see the numerator and denominator clearly. Whether it's arithmetic or it's algebra, it's the same thing. Algebra, arithmetic, very much the same thing. What was step 2? Do you remember? Find the LCM of the denominator. And this LCM was 6, 9, 6, 1, and 12. 36. Then write each fraction. That's indeed step 3 as its equivalent fraction with the denominator of 36. Brilliant. Now, and there we have it. Notice we're using the same numbers. So 9 into 36 is 4. 4 times 2a. 6 into 36, 6. 6 times the numerator is 2a, not a number. 1 into 36 is 36. 36 times 3a. 12 into 36 is 3. 3 times 5a. Okay, and there we have. Remember, how do we simplify algebraic expression? When adding and subtracting, it follows the same principle as directed numbers, focusing on the coefficient. But we must remember, with algebraic, in an algebraic expression, only like terms can be added. What are like terms? Do you remember? I know you do. Like terms are terms that have the same letters and the letters are raised to the same power. Give yourself a hand. I know that's what you said. No, but this one, you notice? Are they all like terms? That's correct, they are. We have only the letter A, and all the A's have a power of 1. So we can add all these together. So we are adding the numerator, and we have 95 A's. And the denominator remains the same, 36. Now here, once again, we have improper fraction. Do we convert it to a mixed fraction here when we're doing algebra? You may, but I generally say it's best not to. We want so that to ensure the A is, we are not confused with the A and the whole number. But if you do, remember, write the A so that it's beside, right in the middle of the mixed fraction. But it's a practice I don't like to do. And I don't encourage you to do that. Now, example 2. Remember the steps. Tackle this one for yourself. Don't be afraid. I know you can do it. Let's go. Let us check to see what you have. Is that what you did? The denominator here is algebraic expressions. Did you get 12AB for the denominator? Brilliant. How did we get it? Looking at the coefficient, 4 and 3. What's the LCM for 4 and 3? 12. Now we write down all the letters that are different. They are A and B. And what power do we take? The highest power. What's the highest power for A? That's correct. It is 1. Are you tempted to say there is no power? Remember, if you don't see a power, the power is 1. B, yes. The highest power for B is 1. Now, how did we get that numerator? 12AB divided by 4A. Yes. Here, we need to recall the laws of indices, or we just cancel for this nice easy one. So 4 into 12 is 3. The A's will cancel, leaving us with B. So we have 3B. 8A, 3B into 12AB. Once again, 3 into 12 is 4. The B's will cancel. So we are left with 4A. Haha. The numerator is 2. Don't forget to multiply the 4A by 2 to get our 8A. Brilliant, brilliant. Let's look at another example. And once again, you're going to try before we do it. Example 3. Okay, for example 3, we have E plus 1 divided by 4 and 2E minus 3 divided by 8. Oh, what a numerator. It is pretty bulky. Don't worry, the same principles apply. Step 1, write it clearly. This one is already written clearly. So we move on to step 2. LCM of the denominator, the LCD, 4 and 8. Yes, did you write 8 for the LCD? Yes. The LCD here is 4 and 8. Now, moving on. What was the third step? There we are. 4 into 8 goes 2 times, and we multiply the 2 by the numerator. 8 into 8, 1 time, and we multiply the 1 by the numerator. Notice the numerator was bulky, so to hold it together, we use our bracket. Anytime you see a bulky numerator, use your bracket to hold it together. And then, once that is done, we're going to be expanding the numerator. I'm sure you remember expanding or the distributive law in this little one. Okay, 2 times E is 2E. 2 times 1 is 2. 1 times 2E is 2E. 1 times -3 is -3. Make sure you keep your denominator. Now, grouping like terms. Remember, like terms. Here, all the terms are not like terms. We have some with E, and we have some without E. So we can only add like terms. And remember, in so doing, we follow the laws for directed addition and subtraction of directed numbers, which is the signs are the same. You add, keep the sign. The signs are different. You subtract and take the sign for the larger. So 2E plus 2E gives us 4E. 2 minus 3, the signs are different. So we subtract, and that will be 1. And we're taking the sign for the larger. Let's put larger in quotation, which is larger. It's truly larger in magnitude than, say, it's a larger number. Because we do know 2 is a bigger number than -3. So it's a magnitude we're looking at. Now, here we have example number 4. Another bulky numerator. Try it. Right? The numerator may be bulky, but the denominator is pretty nice. Okay, now the denominators are 7. Both of them are 7. So what do we have? LCD is 7. Now 7 into 7 is 1. 1 multiplied by our numerator, we have here. Yes, write the bracket same way. It helps to prevent us from making errors. Now, 7 into 7 is 1. Notice on the sign here is -1. Multiplied by our bracket. Take your time and do the distributive law. Don't make careless mistake. Now, 1 times 3A is 3A. 1 times -1 is -1. Now here, it's not 1 times 4A, it's -1 times 4A. See why the bracket is important? How many of you wrote here 4A plus 5? No, no, no. How did we get this -5? It's -1 times +5. -1 times +5 gives us -5. And now we simplify. Remember, only like terms can be added. 3a minus 4a, signs are different. And so we are going to subtract. So 4 minus 3 will be 1. And the one with the bigger sign is negative. So it's negative a. It's 4a. Negative 1 and negative 5. Yes. Now we have both are negative. What is the rule? That's correct. If the signs are the same, we add and keep the sign. So negative 1 and negative 5 gives us negative 6. Remember, keep your denominator. You must keep that denominator. Let's try one more before we close. Now, try that. Look at that numerator. Yes. Okay, let's see what you did and compare it with what I have. Now, here you see that numerator is pretty bulky. Now, the first thing we want to do is expand that numerator so it's not so bulky. So that's the first thing. That's a new step. Yes. So we want to start. If we have the numerator factorized, the first thing we want to do is to expand. Expand the numerator. Don't expand denominator. What we really want to do with denominator is factorize the denominator. But the numerator, we want to expand. So it's expand numerator, factorize denominator. We will get to cases where we have to factorize denominator in the next session. Now, well, expanding the numerator, we have 2 times f gives us 2f. 2 times negative 1 gives us negative 2. 5 times f gives us 5f. Notice we are not saying negative 5. The 5 is all, the negative is separate from the 5. It's the operation. So we are keeping the 5 right over in the numerator, not carrying the negative. So 5 times f, 5f. 5 times negative 3, negative 15. See? We write back the negative between the two fractions. Now we continue with the steps before. Now this is now looking like example 4 and 3 that we did before. And we pick up. So only one new thing with this bulky numerator is that we expand the numerator first. And then we are back to example 4 and 3. And so there, LCM of 9 and 6, 18. 9 into 18, 9 into 18, 2. And we now multiply the numerator by 2. Bulky numerator, bracket. Bulky B, bracket B. Bulky numerator, bracket. Don't forget, write back our operation, subtraction. 6 into 8, 3. Bulky numerator, bulky B, brackets. 5. So 6 into 18, 3, and 3 multiplied by our numerator. Expanding, we have 2 times 2f, 4f. And 2 times negative 2 will give us negative 4. Please note this should be negative 4, should be 4f. Negative 3 times 5 is negative 15f. Negative 3 times negative 15 is positive 45. Now, like terms. So here, notice this time I'm writing the number first, constant first. Doesn't matter whether I write the term with the letter first or the term with the number first. Anybody know why I wrote 41 first this time? That's correct. The 41 is positive. And normally if we have a positive number, we like to write it first. 45 and minus 4 gives us positive 41. The signs are different. We subtract and keep the sign for the larger. 2f minus 15f, that gives us 13f. And that's it. So let's go. Remember, with God, all things are possible. Remember, I can, I will, I must better my best. With God, all things are possible. And remember, Jesus loves you. The end.